Let's kick things off with a quick discussion about the term actuator. Now, if you're new to this concept or are looking to deepen your understanding, our industrial sensor skill path at the RealPARS learning platform might provide valuable insights that you'll find extremely useful. So, what is an actuator? If you do a quick Google search, you'll find lots of different answers. Analyzing the responses yield a common theme. An actuator is a device that makes something move or operate. Okay, digging a bit deeper, we find that an actuator receives a source of energy and uses it to move something. In other words, an actuator converts a source of energy into a physical-mechanical motion. There are three sources of energy used by an actuator to produce the physical-mechanical motion. Pneumatic actuators are operated by compressed air. Hydraulic actuators use a variety of liquids as a source of energy. And electric actuators use some form of electric energy to operate. Let's look at some typical examples of actuators. A pneumatic actuator receives a pneumatic signal through a top port. This pneumatic signal exerts pressure on a diaphragm plate. This pressure will move the valve stem downward in a way that moves or strokes the control valve. Here's an example of an electrical actuator operating a butterfly valve. As the motor operates, the butterfly valve will open or close. And finally, here's an example of a hydraulic actuator on a dump truck. The extending hydraulic actuator lifts the box. As the industry becomes more and more dependent on automated systems and machines, the demand for more actuators increases. Actuators are used extensively in a multitude of manufacturing processes, such as assembly lines and material handling. With the advances in actuator technology, there are a vast number of actuators at our disposal with different strokes, speeds, shapes, sizes, and capacities to best satisfy any specific process requirements. Without actuators, many processes would require human intervention to move or position many mechanisms. This is a good time to introduce you to the device called a robot. If you're interested in robotics, we have a great course in our robotics skill path that can help you identify different robot models, understand mechanical unit basics, and even guide you through installing FANUC's simulator tool, RoboGuide. But let's get back to our discussion here. A robot is an automated machine that can execute specific tasks with little or no human involvement, and with speed, accuracy, and precision. These tasks can be as simple as moving a finished product from a conveyor to a pallet. Robots are very good at pick-and-place tasks, welding, and painting. Robots are excellent at doing tedious, repeatable tasks that were performed by a human a few years ago. Robots can be used for more complex assignments, such as manufacturing automobiles on an assembly line, or executing very delicate and precise tasks in the surgical operating room. Robots come in many shapes and sizes. The type of robot is defined by how many axes are used. The main component of every robot is the servo motor actuator. For each axis, there is at least one servo motor actuator that moves to support that part of the robot. For example, a 6-axis robot has 6 servo motor actuators. A servo motor actuator receives a command to go to a specific position, and then acts on that command. Interested in understanding how to jog such a robot? Our robotics course covers that too. We can't end this video without discussing some of the new trends in actuator technology. There's a new device emerging called a smart actuator. This smart actuator contains an integrated sensor. This device is capable of providing actuation or movement in response to sensed physical properties, such as light, heat, and humidity. You'll see smart actuators used in applications as complex as nuclear reactor process control systems and as simple as home automation and security systems. Peering into the near future, we see a device called a soft robot. What's a soft robot? A soft robot has soft actuators integrated and distributed throughout the robot, unlike a hard robot with actuators for every joint. Adding artificial intelligence to the mix, biomimetic intelligence provides a robot with the ability to learn new environments and the decision-making ability to respond to external changes. Before we wrap things up, remember, if you're intrigued by the world of robotics and industrial sensors, we have an ideal place for you at the Real Pars Learning Platform. Our robotics course will teach you to identify FANUC robots and controllers, understand the need for batteries, and much more. Additionally, our industrial sensor skill path provides various practical courses to get you up to speed in this critical area. We're continuously adding new courses, so keep an eye out for future editions. Links to these learning paths are in the video description. Thank you for your time, and happy learning!